So the OBS selection is 2 to 5 degrees. CDI is showing 2 dot fly right indication on a 5 dot system. Aircraft is moving to the station with a drift of 10 degrees starboard and 2 from indication, the flag showing you from. You're asked to find out the radial of the aircraft, heading of the aircraft, type of sensing, area of reading, distance off track if VOR is at 120 nautical miles from the aircraft. Yes, I'll give you some time, 60 seconds. First, you're asked to find out, the OBS was given 225, CDI, this is a huge information where CDI is a 2 dot fly right on a 5 dot system. So what does it mean that CDI is showing you 2 dot fly right on a 5 dot system? 2 dot fly right. So how much is it?
Oh.
It's 4 degrees, right? And it's indicating you to fly right by 2 dots, right? Plus to the station, and you have a drift of 10 degrees starboard and a from flag. Now you see this combination of information here. To the station, which means the aircraft is moving to a station with a from flag. So what do you understand from that?
The reverse sensing.
It's a reverse sensing. Now look at these two combination of data given. The OBS is given as 2 to 5, and then you have a from flag. So where is the aircraft? Is the aircraft on the tail side or on the head side of this 2 to 5 radial?
So the desired radial is
2 to 5. Yeah. Is the aircraft on its head side or tail side for the flag to be from?
And for the flag to be from, we have to be on the head side.
That's right.
So we are on the 2 to 5 side.
So you're coming to the station and you're on the head side. So I'm just trying to derive some information without drawing the actual picture, just to give you the orientation. Now let's draw the diagram. The desired radial is 2 to 5, so this is 270, which means 2 to 5 radial is somewhat in this direction. The radial is always that part which is from the station, therefore this is 225 degrees is the radial. Perfect. Now the CDI is showing 2 dot fly right with a reverse sensing. Now this, if once you get this information as a reverse sensing, now if you look at the combination of these two information, one saying that the CDI is showing you 2 dot fly right, the other is showing you that it's the reverse sensing. Where is the aircraft?
So if it's showing 2 dot fly right, if it was commands, then we have to fly left. So if it was commands, then we have to fly right.
That's
in
right.
actual.
If it is a command sensing, with this kind of an indication, you have to follow what it says, which means you have to fly right.
Yeah.
Yes.
So in this case, we have to fly left actually.
Why?
Because it's a reverse sensing.
Very good. Since it's a reverse sensing, you have to follow exactly opposite of what CDI is telling you. 2 dot fly right, so the action should be 2 dot fly right, fly left. 2 dot fly left. Now, 2 dot fly left for what? Fly 2 dot to the left for what?
To go on the desired radial.
Exactly, to center the needle by getting on a desired radial. So where should the aircraft be? Remember, the aircraft is coming to the station and we determined that it is on the head side. So where is the aircraft, if at all you want to look for it? If I divide this into with perpendicular radials, this is going to be the head side or the front side, and this is going to be the
on 2 to 1 radial.
So the aircraft has to be somewhere here, not here, because it's coming to the station, but it's on the head side. So you see, it's on the head side, which is right here, but we are looking at an aircraft that is somewhere oriented in this direction because it has to come to the station, somewhere in this direction. We have to find out the heading of the aircraft in the question. So you have to find it out. But basically, I'm looking at an aircraft somewhere of this heading in this side, not on this side. Does it make sense? Right? Yes. Now, where should I place the aircraft? Should I place the aircraft to the north of 2 to 5 radial or to south of 2 to 5 radial?
Place south.
Exactly, you have to place it south. Because I have to move 2 dots fly left to reach the radial, which means my aircraft has to be to south. Only then a left heading is going to make me intercept the radial. If I am on the north of the radial, a further left travel would take me further away, and the needle is now going from 2 dots to 3, 4, and 5th dot and get stuck there eventually. Right? So the aircraft has to be placed to south of the desired radial. So understand the concept. There are certain questions where they have asked where's the aircraft, and the options were like south of desired radial, on the desired radial, and north of desired radial. This is what they mean by that. South, or you can say sometimes it can be east or west, depending upon the orientation of radial, that can change, right? This is more like the southwesterly radial, right? And what is the radial of the aircraft? So the aircraft is somewhere here.
Radial is 2 to 1.
Exactly. So basically, what is this angle between the radial of the aircraft and the desired radial? That is 4 degrees. That is why it is showing you 2 dot. So it's 4 degrees, right? Therefore, 2 to 5, 4 degrees to the anti-clockwise direction. Do you see how you can develop the question, the answer yourself by taking combination of data given? Don't just get fixated on one particular data and see what can be done. Just by seeing 2 dot fly right, you have 2 possibilities. It could be reverse sensing, it could be forward sensing, and depending upon that, your actions may vary. Right? So what is this radial? This is going to be 2 to 1 degrees is the radial of the aircraft. So what is the aircraft radial? Is 2 to 1 degrees magnetic. Now, what is the track of the aircraft? You think logically.
Flying to the station.
Exactly, that's right. So the aircraft is flying to the station on 2 to 1 radial. Yeah.
So the track is 031.
Exactly. So how do you find that? It's 2 to 1 minus 180, right? Therefore, that is 031 degrees. Magnetic is the track of the aircraft. Remember, if you are moving towards the station, your track is opposite radial, and if you are moving from the station, your radial and your track is equal to a QDR. It's the same. Now, what is the requirement of a track here? Because you asked heading in the question. If I want the heading and if I have the track, what else do I need to find the heading from the track?
Drift is
That
there.
is drift. What is that? Drift is given here.
Drift is 10 degrees starboard.
Starboard. You see, in these kind of questions, the use of drift is to find track or heading, depending upon what is given, right? 10 degrees starboard drift means track is starboard of heading. If the track is 31 degrees magnetic, what is the heading?
021.
That's right, it is 031 minus 10, which is 021 degrees magnetic. This is the time where I can actually place the aircraft. Now I have to place the aircraft on the radial 221, which is exactly on a track of 031, with a heading of 021, which means the aircraft's heading is to the port, and that is why you have a drift to starboard. The track is starboard of heading, and this is 021 is the heading of the aircraft. Right, that's it. Now look at the CDI indication. Here it's 2 dot because it is 4 degrees in a 5 dot system. Actually, you have to fly left, and since you have a reverse sensing here, it's a fly right indication. And why do we have reverse sensing? Because we are moving to the station, but with the from flag. Right? So that is it. Now, what do you think will be the ADF indication? So the RMI, just in case if there is an NDB here, or in general, what do you think will be the VOR RMI indication if the VOR receiver is an RMI? So what is the, if it's an RBI?
So 010 on RBI.
Exactly, 010. Why is it 010 degrees?
Because we are flying to the station.
Exactly, to the station.
And 10 degrees starboard drift.
That's right, 10 degrees starboard drift to the station. Yeah, otherwise you can see that this angle itself is 10 degrees. In case of an RBI, the head of the RBI is 0, and therefore it's going to be 10 degrees. Right? What if it is a VOR? And in case of VOR, the indication will be RMI indication. Yes.
RMI.
Or an ADF RMI. Doesn't matter VOR RMI or ADF RMI. It's going to be a same. What is the indication? It's going to be show
So
you
the tail will indicate the VOR,
QDM.
the radial.
That's why the tail is going to indicate the radial QDR. Therefore, what is the head going to indicate? It's simply going to indicate QDM, magnetic
QDM.
track to the station. What is the track to station?
Track is 031.
That's right. It's equal to track of the aircraft, right? Therefore, that is going to be 031 if it is a VOR RMI or AD of RMI, doesn't matter. It's going to indicate the same.
So the head, so on the dial, it will indicate the heading.
Yeah. RMI?
Yes. No, VOR. Yes.
VOR RMI. Right? You can see what is the heading of the RMI. VOR or ADF doesn't matter. It's the head of the RMI is going to be the heading, which is 021, and that's going to indicate QDM, which is.
And QDM will be so QDM is the track to the station 031.
That's right. That is somewhere here. Once we get 021 as a heading, 031 is here. The head of the RMI indicates QDM. What about tail?
The radio.
It's QDR, which is the radial of the aircraft, which is 221. So you can see the different means by which you can cross-check the answers. All these things should be in line. Right? Perfect. Yes. Now you can again see the application of 160 coming up here. In the last part of this question, they are given distance of track if VOR is at 120 nautical miles from the aircraft position. You see, you are supposed to be on this track. Now you can see again, you can see a problem here. The air traffic controller is asking you to coming inbound to VOR by on a radial of 2 to 5. And if I OBS the exact radial which I hear on radio, I'm going to now experience a reverse sensing. So if I'm coming inbound, if I'm clever enough, I would probably OBS the opposite radial. Even if they told me 225, I will just do 225 minus 180, which is 45, and I will OBS 045. Thereby, this will become forward sensing. And now you can just follow, or command sensing, and you can just follow the instrument straight. Right? Perfect. Now, it says that the aircraft is off the desired track. The desired track is this radial. The aircraft is off this track. You have to find out what distance is the aircraft off track. If the aircraft is 120 nautical miles from the VOR, imagine there is a DME here which is giving DME distance or something, or GPS distance, and that is 120. And you can see, can I apply 160 here?
Yes.
Why?
Because we know the track error.
Which is?
We know the distance to go.
Since you're closing towards the station, this is more like a closing angle, but still that angle is less than 20, and therefore I can use 160 here, right? And since applying 160 here, I can find distance of, what is the distance to go? Distance to go is actually this distance here, which is 120, but you can take these two distances as same because the angle is smaller, right? So applying 160 on this particular triangle here. So what is 160? Closing angle is equal to distance off by distance to go into 60. So you have to find out distance off here. Distance off is equal to closing angle into distance to go divided by 60. What is closing angle? Closing angle is 4 into distance to go is in nautical miles. Yes, it's 120 nautical miles. You don't have to do this. We can simply apply the normal 160 principle here. For every 60 nautical miles, 4 degree corresponds to 4 nautical miles. Therefore, 120 nautical miles will correspond to
8.
Let's see, divided by 60, which is going to be 8 nautical miles. So you can think in that way as well. Without using the equation, by normal understanding of 160, you can find out which is 8 nautical miles. Right? So you have to find out radial of the aircraft. We have found out that heading of the aircraft, type of sensing, ADF reading, distance off track if the VOR is at 120 nautical miles from the aircraft's position.